Hello viewers, welcome once again. In this tutorial, I will teach you how to calculate for the z-score of a given score data. But by the way, what is a z-score? A z-score simply means a standard score which is measured in terms of standard deviations from the mean. Take note that your z-score could be either a positive value or a negative value. And a positive z-score simply means that your score is above your mean, while a negative z-score simply means that your score is below your mean. Let's go ahead to read out the question we have on the board. We are asked to compute the z-scores for the following raw scores obtained by 5 students in a chemistry test. And the scores are 58, 72, 66, 62, and 59 respectively. Let's go ahead to state the formula for calculating the z-score of a given score. The formula is given as your z-score, which is equal to your x minus your mu, and that is all over your standard deviation. The x here stands for your score, while the mu here stands for the population mean. The population mean, and this is a sigma, then that is actually the lowercase of sigma. The uppercase is this, and the lowercase is this. So this is the lowercase of your sigma, which stands for your standard deviation. Standard deviation. So take note that this formula is used when we are calculating for our population data. Population data. But if we are calculating for the sample data, our formula will change to our z-score, which is equal to our x minus our bar x, which is our mean. So this bar x or x bar is our mean. But this one is not just the population mean now, but the sample mean. The sample mean, and that is all over our standard deviation. Our standard deviation. So the SD stands for the standard deviation. Okay, so this other formula is used for calculating for our sample data. Sample data. So if we want to calculate for the z-score for our population data, we use this formula, while we can also use the other formula which I stated here when we are trying to calculate for the z-score for the sample data. Then pertaining to the standard deviation, there is a different formula for calculating the standard deviation for a sample data, and also a different formula for calculating the standard deviation for population data. So for the population data, the standard deviation will be given as our sigma, which is equal to the summation of x minus our bar x all squared, and that is all over our n. But for the sample data, our standard deviation will be given as SD, which is equal to the summation of our x minus our bar x. Bar x is the mean, all over our n minus 1. That means we must subtract 1 from the total observation, which is our n. Take note that the n is the total observation. Alright, let's go ahead to find the z-scores for this individual scores here. I'm considering these scores as my sample data. Hence, I will use this second formula. But if I'm considering these scores as my population, I will use the first formula. But I'm considering these scores as my sample data. Hence, I will use the second formula. And from the second formula, to find the z-scores for these individual scores, there is need for us to find our mean first of all. After which we find our standard deviation before we begin to compute for the z-score. And to find our mean which is bar x, or x bar, is given as summation of x all over our n. That is the formula for calculating for mean, which does not involve frequency. And our x here is just to sum every individual scores we have here, which are 58 plus 72 plus 66 plus 62 plus 59. And that is all over. Our n is the number of observation, which is 1, 2, 3, 4, 5. So the number of observations we have here is simply 5. And that is equal to, let's add up all the values we have here. Adding up with your calculator the values we have here, we have that 58 in addition to 72, in addition to 66, in addition to 62, and in addition to 59. And that is summed up to be 317. So here I have 317, and that is all over 5. So when we divide 317 by 5, when we divide it by 5, I have 63.4. So our mean, which is our bar x, is 63.4. So this is actually our mean value. Alright, since we found our mean, let's go ahead to find our standard deviation. And remember the formula for standard deviation for sample data, because I'm considering this set of data as sample data. The formula for standard deviation is summation of x minus by x. To make it more convenient, we shall draw a table. And drawing a table, I have this. The first aspect of the table is our x, which is our individual scores. Let me arrange these scores in ascending order. That is from the smallest to the biggest. I have 58 first, followed by 59, followed by 62, followed by 66, and followed by 72. Alright, from the next parameter is our x minus bar x. So here I have my x minus my bar x. And what is x minus bar x? It simply means subtracting your bar x, which is your mean value, from your individual scores. So let's go ahead to do so. So the first one I have here is 58 minus 63.4. So I punch with my calculator 58 minus our mean, which is 63.4, and that will give us negative 5.4. Negative 5.4. Then the next one is our x, which is 59, minus our mean, which is our bar x, which is 63.4. So I go ahead to press my calculator. So I have 59 minus 63.4, 63.4. So I have negative 4.4. The next x is my 62. So 62 minus 63.4. So here I have 62 minus 63.4. So here I have negative 1.4. The next one is my 66. So here I have 66 minus my 63.4, and that will give me 2.6. Then the next one is 72. So I have 72 as my next score, minus my mean, which is my bar x, which is 63.4. So I have 8.6. Alright, let's go ahead for the next column. For the next column, I have the combined parameter. Sorry, I missed my square here. I have the combined parameter of x minus bar x all squared. So here we have x minus bar x all squared. This simply means to square all the values we have here. That is very simple. So let's begin to square. For the first instance, we have in brackets negative 5.4. Negative 5.4, then all squared. That is raised to the power of 2. And that will give us 29.16. Then for the next one, we have negative 4.4. Negative 4.4. You close your brackets, raised to the power of 2. And that will give us 19.36. For the next one, we have negative 1.4, negative 1.4, then raised to the power of 2, and that will give us 1.96. For the next one, we have in bracket 2.6 raised to the power of 2, and that gives us 6.76. And the next one, we have in brackets 8.6, 8.6, then raised to the power of 2, and that will give us 73.96. So these are our combined parameters, and we have the summation of everything we have here all squared. That means we shall sum it here. So here we have the summation of our x minus our bar x squared, which is to sum everything we have here. And summing them together, let's begin. We have first one 29.16 plus 19.36 plus 1.96 plus 6.76 plus 73.96, and that will give us the total of 131.2. So that is for our summation of everything we have here. Then remember that our n is just the total observations we have, which are 1, 2, 3, 4, and 5. Okay, so our standard deviation, which is our SD, is equal to the summation of everything we have here. We summed it to have 131.2, and that is all over. Our n is the number of observation, which is 1, 2, 3, 4, 5. So we have 5 minus 1, because we are considering the sample data, and that is equal to 131.2, then divided by 5 minus 1 will give us 4. And when we solve further, we have that 131.2 divided by 4, that will give us 32.8. So our SD, which is our standard deviation, is 32.8. 32.8. Okay, having found our standard deviation, let's go ahead to compute it in this formula to find the z-scores for these individual scores here. Sorry, I will wipe the board to enable me complete my calculations. Alright, let's go ahead to find the z-scores of these individual scores here. Remember, we are using the second formula still, and that is for our z equal to x minus by x all over our standard deviation. So to compute for this score, which is 58, so I will replace this x with 58, then minus our bar x, which is our mean, and we calculated the mean and we have it as our 63.4. So here we have 63.4, and that is all over our standard deviation. Sorry, I'm talking about here our standard deviation. And what is our standard deviation? We found it to be 32.8. So here we have 32.8, and this is equal to, let's calculate with our calculator. So we have 58 minus 63.4, and that is equal to negative 5.4, and that is all over our 32.8. And this is equal to, we have that when we divide our negative 5.4 by our 32.8, so we have negative, let me write it here for convenience, we have negative 0.16 approximately to 2 decimal place. Alright, then the z-score, remember the next column, if you want, you can just include it as a z-score. So here is our z-scores. So the first instance we have negative 0.16. So negative 0.16 is the z-score of this 58. That is the standard score of this score value of 58. Alright, let's also find the second one. The second one is 59. So from the formula, our x is 59, then minus our bar x, which is our mean, which is 63.4, and that is all of our standard deviation of 32.8. 32.8, and that is equal to, let's go ahead to punch the calculator. We have 59 minus 63.4, that gives us negative 4.4, and that is all over 32.8. And when we divide negative 4.4 by 32.8, we have the value which is negative 0.13, approximately to 2 decimal place. So here we have negative 0.13 as the standard z-score for the score 59. Then also for the third one, we have our 62. So we have here 62 minus our mean, which is 63.4, all of our standard deviation of 32.8, and that is equal to, with my calculator, 62 minus 63.4, and that will give us negative 1.4 all over 32.8, and that is equal to, when we divide by 32.8, it will give us negative 0.04, approximately to 2 decimal place. We have negative 0.04 as the standard score for this 62 based on the z-score. Then the next one, which is the fourth score, is 66. So I have 66 minus our mean of 63.4 all of our standard deviation of 32.8, and that will give us we have 66 minus 63.4, it will give us 2.6, and that is all over 32.8, and dividing further, we're going to have 0.008, approximately to 2 decimal place. So here we have a positive value of 0.08. Remember I said prior that your z-score could either be negative or positive value. Take note of that. So here we have some negative values, and we have for some positive values as well. Let's go for the last one. Let me compute it here because of space. So we have 72. So that is the last z-score. We have 72 minus our mean of 63.4, and that is all over our standard deviation of 32.8, and that is equal to, so here we have 72 minus 63.4 will give us 8.6, and that is all over 32.8, which will give us total of 32.8, total of 0.26. Okay, so here we have the last one, which is 0.26, 0.26, approximately to 2 decimal place. All right, this is actually how to calculate for the z-score of a given scores. We've claimed the board already, we have the scores, so automatically if you're asked to find the standard scores of these scores based on the same, we also have other standard scores like t-scores, but we are precisely talking about z-score here. So the standard score for all these individual scores are the negative values of 0.16 and the rest. So take note of this, and take note that whenever you have a standard score of negative value, it simply means that your score value is automatically below your mean value. While whenever you have a positive values like what we have as 0.08 and 0.26, it simply means that your initial score, which are these scores, is above your mean value. This can easily be seen when you plot or sketch it on your graph sketch. Thank you for viewing. Thank you for watching. If you found this video useful, remember to reshare this video, and as well subscribe to my YouTube channel. You can as well follow me on Facebook. Remember to reshare this video. Goodbye.